Hey, good evening, and welcome to the Journal of the American College of Radiology's Journal Club. We're so glad you could join us this evening for tonight's discussion, Building the Future of Radiology with Artificial Intelligence. A special thank you to Dr. Jen Nathan and the other members of the ACR Centennial Future of Radiology Committee for helping to plan tonight's program. My name is Christoph Wald, and I'm a radiologist at the Leahy Clinic in Boston, and currently also serve as chair of the IT Commission for the ACR. It's my distinct pleasure to host this discussion tonight, which I sincerely hope will be somewhat stimulating. We have a great panel of colleagues here with us tonight who have been thinking about how that future will look like, who are coming at it from very different perspectives, so I'm excited to hear about that. Rather than rattling off a long list of names and titles, I'd like to go around our virtual stage and ask each of our esteemed panelists to introduce themselves. So please, friends, tell our audience who you are and what your interest is in AI and emerging technology. What compelled you to participate in a conversation regarding the intersection of AI and clinical radiology? And sort of in no particular order other than what I see on my screen here, I will start with Jim Thrall.
So I'm Jim Thrall, Chairman Emeritus of the Department of Radiology at Mass General, former chair and president of the American College of Radiology. And I was excited to be on this panel because I think AI is going to be transformational in all of healthcare, including radiology. We need more awareness, more education, more knowledge in radiology. And I'm delighted that the American College of Radiology is taking a leadership position in bringing radiology into the AI era.
Thank you, Jim, for joining and for all of the thought process that you've already put in this in the past, which we're going to get to. So next on the screen is Keith Dreyer. Keith.
Thanks, Christoph, and thanks for the opportunity to be part of this esteemed panel. I'm Keith Dreyer. I'm a diagnostic radiologist, used to work for Jim Thrall for a long part of my career. And I kind of lived my life at this intersection of radiology and technology, spending most of my time putting technology in at Mass General Hospital. And since 2016, 2017, that's been artificial intelligence. I'm currently the Chief Data Science Officer at Mass General Brigham, but I also have the honor to serve as the Chief Science Officer at the Data Science Institute. I think that this is really a challenging time for medicine in general. There's an incredible amount of burnout. People are looking for solutions. People are asking the question of, can AI deliver on that opportunity? I think that's one of the things that we can talk about here. There's also a transition that hopefully we'll get the chance to talk about of the old-fashioned way of doing AI, which is, as of 2 years ago, and the new way of doing it, which is as of 6 months ago, which takes us from old convolutional neural networks into generative AI, large language models. You've probably heard things like ChatGPT and those kind of things. So I think it's a transformational time for the field. And I think it's a great opportunity to start to hold true on some of the promises that AI has always delivered or tried to deliver to the field and to healthcare in general.
Great. Thank you so much, Keith. It's awesome to have you here. And you better believe I'll get back to you on the LLM. So let's go next to Ashley Prosper and the other coast. Oh, Ashley, you're muted. I can't hear you. We'll come back to you. Oh. Okay, we'll come back to you. Why don't we go to Bibb Allen, who's our other panelist?
Good evening, everybody. I'm Bibb Allen, and I'm going to start out by saying that data science is not something that I knew very much about in my career in radiology. I got involved with data science actually when we were starting some of our value proposition initiatives at the college back. I did some of the same, most of the same things that Jim Thrall did. I've been an officer of the college, and when I was chair, we had our initiative for value-based care, and it was informatics that was able to make our specialty implement some of those things. And I got really involved in how we could leverage information technology to do those things as part of the ACR's Imaging 3.0 initiative a number of years ago. And as I became past president of college, I had the opportunity to be involved in the ACR's Data Science Institute with Keith as sort of the chief medical officer, sort of the one who's not going to build anything really cool, not going to do the one to write the code, but more to say how can AI help radiologists be better? How can we do better? You know, those of us, except for Ashley, you know, have lived through the glory days of radiology with the advent of CT and then MR and then PET and all of this modality stuff. But I think that if I could start over again, I think AI has the real opportunity to transform our specialty once again and make us even more valuable to the patients in the healthcare system. So thank you for inviting me.
Great. Thank you so much for being here, Bibb. And I think Ashley is back live with us.
Hopefully you can hear
Yay!
me now.
It worked.
Yes. So Ashley Prosper, I'm a cardiothoracic radiologist. I've had the pleasure of interacting with my co-panelists in a variety of ways, including on the Informatics Commission. As a cardiothoracic radiologist, I'm really intimately involved in lung screening, and I think a lot about population health. While it's really important for us to provide high-level, excellent care at the individual patient level, I'm always thinking about how we can expand that and how we can extend that care to a larger population. And I look to AI to help me achieve that, because as an individual radiologist right now, I have limited capabilities to get things done within a 24-hour day. So really excited to talk about ways that we can use these new tools to extend the care that we provide.
That's a really great perspective, Ashley, because it talks to the scale and scalability at which this technology could function in the future. So we'll get back to that in a moment. Jim, let me start with you. You know, in 2017, you wrote a JACR article together with Keith and Jim Brink from MGH and others called Artificial Intelligence, Machine Learning in Radiology Opportunities, Challenges, Pitfalls, and Criteria for Success. So it's now 6 years later. You have the luxury of the rearview mirror. Yeah. Which of the statements that you made do you think held up? And what's surprising you now about how things went so far? You know, specifically, you know, how's the adoption of AI into imaging practice been unfolding in your perspective?
So, Chris, thanks a lot. I occasionally reread the article and test what's in it against what I'm seeing, and it has held up remarkably well. Keith can comment, but I don't think there's anything we said in the article that is proven to actually be incorrect. But on the other hand, it's 6 years old, and we didn't know about generative AI or large language models at the time. And so we couldn't comment on how they might be important, you know, what the criteria for success would be and what the pitfalls would be. But there is one thing that I wish we had emphasized even a little more than we did, and that is the challenge of generalizability or applicability. And all of AI is predicated on training a program, whether it's a neural network, whether it's a large language model. And so the quality of what comes out of the program is based on the quality of the data that goes into it. And more importantly, probably, is the fact that if the data that goes into the program, whether it's a neural network based program or whether it's a large language model, if the data that goes into the program is different than the characteristics of the population on which the program is used, the accuracy degrades. And one of the concerns I have is that this has not been emphasized by the FDA, and I don't think the field in general has appreciated this challenge of generalizability enough. And again, I would emphasize both for the neural networks and for the large language models. So that's something that we completely missed because we didn't know about it. And, if motivation strikes, maybe I can get Keith and others to think about how that fits in.
Yeah, that's a really great point, Jim, especially also because manufacturers currently tell customers relatively little about their technology, about the types of data it was trained on, about the types of patients it was trained on. So this is actually quite challenging to understand how the technology came about. And you will see over time, probably later this year, that we're really trying to address this with ACR at aicentral.org, recognizing that. I think the other challenge that will probably come up in discussion is that practices are probably poorly tooled to see systematically how well the technology works or doesn't work, because we haven't had traditionally to incorporate that technology into our production systems. And so it's new. It's the new kid on the block. And I think our production systems and quality assurance systems just haven't been designed to systematically monitor that performance. So I think that's a to-do for us collectively.
Yeah, and if I could follow up on that, Chris,
Please.
Your remarks are absolutely correct. And this, again, is why I think it's so important for the American College of Radiology to be a central player here, because the college is a convener of thought leaders, a convener of radiologists and industry, a convener of the federal oversight, the FDA oversight, and the standards that should be developed in this area. And so I think we can take, through the ACR, a leadership role in addressing this open-ended question.
Yeah, we're certainly trying to do that with everybody's help. It takes a village. Now, I'm going to switch gears here and sort of put Ashley on the spot. Ashley, you may be aware of Jim's article where we're sort of starting to discuss what may or may not have panned out there. As you listen to all of this, and as an earlier career physician, are you excited or concerned of the future? I think you already gave that away a little bit in your initial remarks. Are you excited for radiology or for radiologists? What do you think is the biggest promise, and what do you think is the biggest threat coming from this for someone like you?
Thanks, Christoph. Something that I think is really exciting is what Keith mentioned. There's a lot of burnout. People are facing so many tasks in a given day. The volumes are higher. The expectations are greater. If we have tools that are trained appropriately and vetted appropriately and are consistent and accurate, that has the potential to alleviate some of the current high level of tasks that we have to achieve in a day, particularly some of our more mundane tasks. So for example, as a cardiac imager, I spend a significant amount of time contouring the left and right ventricle for volumes. I've not yet seen a fantastic AI model to help me achieve those. That would eliminate a lot of the sort of mundane work that I have to do to get to a report. Something that I worry about is, as was just mentioned, tools being put out into the marketplace that are either trained on a population that is not the population that the algorithm is going to be used on, or it's just not vetted well at all. Some of my colleagues here at UCLA, they recently put out an article on generative AI and evaluating questions that patients might ask products like ChatGPT or Bing or other programs about things like lung cancer. And one of the most concerning findings was that a lot of these generative AI models, instead of just saying we don't know or we don't have the answer, they would provide a false answer. And so that's exactly what we hope to avoid, is a model giving us an answer that's incorrect instead of just saying I can't help you. So these are some of the things that are on the forefront of my mind.
Yeah, I think that's really good, and sort of keep weaving that into the discussion, because we're really interested in your perspective. The only reason I say that is I spent a lot of time on screen, certainly with Keith and Bibb, and and getting additional perspectives is always extremely helpful. So thank you for that. Several of you have actually already made mention of large language models or generative AI, whichever term you want to use. And so that is, in fact, the latest rage. Certainly has popped onto the public scene late last year and is rapidly taking many professions by storm, including our own, although the non-regulated professions are certainly more affected, marketing and so forth. So let's talk a little bit about that. We've sort of prompted Keith to put a little bit of information together. Let's talk about large language models for a moment. We actually recently launched them in a member-facing manner at the annual meeting of the ACR at our DSI booth. And Keith was so kind as to give a talk at the Data Science Institute Summit a couple of weeks ago. And so I'm going to ask Keith, for the benefit of the audience and everyone here, to sort of give an encapsulation of that talk. Would you please discuss sort of the transformational potential of this technology as it gets incorporated into radiology practice? So Keith, I'll put you on the spot on that one.
Sounds good. Sounds good. Most people that know me know that I can't talk without PowerPoint. So Abby, can you put up some PowerPoint? Perfect. Thank you. So this was the title here. It's this triple transformation. And next slide, I'll talk about what those are in my mind. I was just kind of thinking back. Next slide. Yeah. So basically, there are 3 different transformations that we lived through. Sorry for some of the formatting here. As the first 100 years of radiology took off, all these modalities started coming into place. And so they were really driven by clinical needs for screening, diagnosis, staging, and planning. But the next one we saw was, starting in the 90s, this whole digital transformation where film went away. And it was really for efficiency and savings and quality, the operational initiatives that did this. Although there was some upside as well, teleradiology kind of took off through that, as well as preparation for artificial intelligence, kind of the hope that it would come. And for those of you that remember those days, it was early CAD for mammography, et cetera. And then most recently is this whole AI transformation, and it's just starting. So it promises to do computational activity like analysis, assisting, predicting, interpreting, recommending, and at some point autonomy. Next slide. If you look at transformations in general, I think that we can see that AI is going through the same thing. So the early days of technology is really when the functionality starts to become established. When you get into the middle of the transformation, you're increasing penetration broadly. It becomes much more stable, much more reliable. And I think this is kind of what Ashley's speaking to is, it's early. So this stuff does crazy things you don't design it to do. You got to get the bugs out, and that just takes time. And then when it gets to the mature point, you've got this real high reliability, very widespread. It becomes very, very ubiquitous. Next slide. These are really pictures of telephonists and telegraph operators. And next slide. So you'll see that, oops, can you back up one? Oh, that's okay. Next slide. So what you'll see here is the customer adoption patterns, but also that curve is talking about the effect that this has on the jobs in particular. So as I say, if you look at over time in that early phase, it was really no more additional volume of telephonists and telegraph operators were needed. And it represents about 50 years from the study that was done in the UK. The second, that middle period of time was really when the job started to take off. There was a giant need for telephone operators, for telegraph operators, et cetera. And then the next 50 years in the mature phase, the job started waning off. And it's the same curve that you see for customer adoption. And in the surveys that we've done over the last few years at the ACR, it looks like the market is about 2% penetrated. So we're in that innovator stage. So it's very early days. Next slide. So what does this mean for the pathway that we're going to go down for AI? Historically, what we've seen is we started with narrow AI, as I talked about, these convolutional neural networks that say just find a nodule on CT of the chest, right? And then there's about 1,000 of those things that you have to make. And so the question is, was industry going to go along a faster adoption curve or follow a regulatory pathway? And it's pretty obvious in healthcare, and particularly in our field, that there's a heavy regulatory burden, and there's also a lot of gating functions that will prevent you from releasing solutions that are considered medical devices, which most of these are. So you have to go down that regulatory pathway. Next slide. So what we've resulted in, is a lot of narrow AI. And so Christoph spoke about AIcentral.org, which is what we've set up here, so that you can get a feel for all of the algorithms that are out there, because it's very difficult to understand what this marketplace looks like. There's over 240 algorithms now that are FDA approved that you can consider how to buy. The top left corner here shows you how they're distributed throughout subspecialties and also through modalities. But the box that I drew there in the center and the bottom is talking about this, fast CAGR growth of FDA approved algorithms over the last, particularly 6 years. And this is all off the backs of convolutional neural networks, those single point solutions. Next slide. So this was all, as I said, happened through these convolutional neural networks and recurrent neural networks. And as of late, in the last just couple of years, transformers came on the scene, which is really these foundation models, generative AI, large language models, et cetera. Next slide. So this is what this looks like. So basically, and this is what we were actually able to show at the annual meeting, and also we're going to put this up on AI Lab permanently, so that you can actually look at it and see what comes out. So basically what this is this could be a radiologist view of what they might be doing with generative AI. The left side is a patient's report. There's a previous report behind that. And then the user prompt is in the top, and you can type anything you want. So in this case, they said, please provide all quantitative findings in a table format. And the generative AI response comes back and puts that structure into place. It's pretty amazing. If you've been in this field, there's been nothing even close to doing something like this before. This would have been massive amounts of hand coding, natural language processing, and particular point solution AI. And now this just works in kind of this automatic form. There's a lot of negatives currently to it, as Ashley spoke to with her colleagues talking about these hallucinations and all of these things, but it's still pretty amazing. When I look at that, I can just kind of look over the bumps and say, this is going to really transform what we do. And, as Christoph has said, we forget that we deal in information, not just pixels. And this thing is made all about to understand information and to communicate to humans in a human fashion, because it got trained over the internet. And so it looked at all the data that we've generated for decades, and now it understands how to speak, quote unquote, human. Next slide. Sorry about all this overlapping text here, but basically what you will be able to do. So currently these large language models are just starting to understand not only text, but images as well. So you can picture a state in the future where you could look at a CT like this and get the history, a brief history to say 4-day history of jaundice and nausea, and say, what are the imaging findings? And it could come back and say a 2-centimeter cystic mass in the head of the pancreas. What would be the mechanism that I would use to treat this? And it would just kind of be able to talk to you and converse with that generative AI approach. Next slide. So basically, sorry, this is a deconstructed slide here, but basically the previous pathway that industry has taken is that to the right, the regulatory pathway, making multiple narrow AIs, right? The 240 that I was just talking about. And now there's this adoption path of generative AI. It's almost like when Google came out for searching, everyone just did it. You just figured out how to use it in your day-to-day work. That's kind of what's happening with generative AI, despite the fact that it's got these issues. I think a future state is going to be kind of these two coming together. And that's what I was showing on that combination over there, where generative AI is going to orchestrate all these multiple narrow AIs. Because one of the things I think we can get to here, if you were fortunate enough to have the money to buy 10 or 15 or 20 solutions today in narrow AI solutions, you'd realize what a nightmare it is to try and make those integrated into your day-to-day workflow in a way that doesn't slow you down even more. And so I think that we might call on generative AI to solve some of those tasks. And I think in its current state, it's going to be very difficult to get FDA approved. But if you back off what it is it's supposed to do, and it just acts more like an assistant to kind of put things together for you, then it doesn't become a medical device. And I think that's where we're going to see it probably first used in our space. Next slide. Yeah, so, you know, this fellow Pedro Dominguez wrote this great book called The Master Algorithm in 2015. And he's the one that said it's not man versus machine, it's man with machine versus man without. And this was that curve that I was showing you before. So if you look at 150 years of this deployment of this technology for telegraph and telephone operators, right? Really basically telephones coming into place. The first 50 years, it didn't really impact jobs. It didn't increase them, it didn't decrease them, it didn't have much effect at all. And this is seen again and again with as technology comes in that early phase. Then you get into that middle phase and it really ramps up jobs. There's a giant need for more and more, like imagine radiologists. The problem here is it's going to be much longer to train radiologists than to train telegraph operators. So there's going to be a very challenging time when we get to that phase where this is in the takeoff in the middle phase. And then when we get to the far side of that, if we follow trends like other areas that have advanced technology, it might be a decline in jobs. Fortunately, by these curves, that's 100 years from now. But what I would argue is that it's not this man versus machine, it's man with machine versus man without. Today, I can't think of any radiologist who got fired because another radiologist came in that used AI, right? It's all hands on deck, everyone's burned out, hire as many people as you can, all humans. And I don't think people say AI is going to solve our problem of efficiency, et cetera, today. But that day is coming. And when that comes, I think there's going to be a greater need for radiologists, believe it or not, strangely, and that technology will start to come in. But at some point in the future, it could be that a lot of the functions that we do will be replaced. This is a long way away because FDA's got to prove autonomy, all this stuff. Humans got to get used to being interpreted by machines, et cetera, et cetera. But my point here is that we're in this stage where it's really not efficient enough for us to talk about man versus machine or man with and man without. That's just, we're not there yet. Next slide. Oh, that's it.
Well, thank you so much. That was a tour de force. Thank you, Keith, for sort of putting it all together in one sort of set of comments. There's actually on the JACR homepage, in case you're interested, an opinion piece. It's called New Horizons, the Potential Role of ChatGPT in Clinical Radiology. So that actually discusses in broad strokes some of the promises and some of the things that we need to watch out for. Let me just collect some impressions here from our panel. Jim, you said you missed this one, and fair enough. You know, it wasn't in the public view, so you get dispensation, and Keith did too, by the way. So Jim, when you listen to this, good or bad? What do you think?
Oh, I think it's terrific because I already have one kind of cool application that could be near term. And that is how radiologists do CME. You know, imagine the input data is every case you read in a year.
Right.
And then the user question is, what are the best CME courses that I could attend? And what are the most important articles that I could read? And the great thing about it is, as you come and encounter each new case, the program updates to keep current. So if your practice changes, the recommendations will change at the same time. And I think this is a near-term opportunity for a generative AI program that will help radiologists.
Yeah. Bibb, what do you think? You're excited about it?
Yeah, I'm certainly on the bandwagon for AI and the concept that humans with machines are going to be better than we were. I think one of the things that I've learned so far is that we're not ready, obviously, to trust the care of our patients to machines only. But at the same time, I think that the opportunities that machines are, that they that they'll help us do the things. And we'll talk a little bit more later maybe about being able to see the things that humans can't see, how we look at use cases that actually add to what we do, not as much as some of the low-hanging fruit that we're seeing right now.
Yeah, no, that's so true. And I think Keith already alluded to the fact that even though the technology, the way it hit the public eye with ChatGPT, at its core sort of deals in the currency of natural language, which is something that we all do in our professional space. It's already beginning to show that it can transcend the pixel space, the image space with the language space. It can transcribe and transform one into the other. And so, if you think about what we're doing in radiology as managers of information, upstream information and information that we generate ourselves in the imaging process, combining that, putting out new information in the form of natural language, this is certainly going to be striking right at the core of that process. I'm particularly excited also about two other aspects of this. One is, in my own experimentation, it really seems to be a powerful tool to extract and condense information, massive amounts of information. And now I'm thinking of the large amounts of unstructured information that we have all collectively deposited in our EHRs, making that accessible on a relatively short effort to a radiologist who's interpreting imaging studies and needs to put them in context with the overall patient's picture. This is going to be very helpful, I think. Although we will have to validate the output, but it's really going to be an efficiency enhancer. The other thing that really concerns me for all of us is, unless you are a super specialized radiologist, you're very likely to service 5, 10, 20 specialties. And there's just such an incredible explosion of knowledge and clinical guidance systems and classification systems and so forth. We really do need a multi-purpose Swiss Army knife tool that can bring those systems to bear when we formulate our impressions. And I think to believe that individual human radiologists can keep up with that knowledge explosion is just delusional. And so I think we really need that. Ashley, I haven't gone to you yet on LLMs.
Yeah, well, I think you just really touched on a nerve for me. Christoph, I think about a case that I read with a resident yesterday. I was looking at a patient who had multiple radiation therapies for lung cancer, surgical resections, multiple chemotherapeutic agents, and I saw something really high density in the lung. And I thought to myself, there are two possibilities here. It could be a fiducial marker for radiation therapy. It could be a coil, maybe something bled at some point. If the lung was so distorted, I was struggling to figure out what it was. And this resident and I literally spent at least 20 minutes looking in different places in the chart over the past 10 years for this patient's history to try to get to the right answer, because I didn't want to just spew something in the report. I wanted to find out exactly what it was and when it had been placed. And I thought to myself, I think it was a valuable endeavor. It was a valuable endeavor for the trainee to see, how you actually get down to this information, but it was woefully inefficient. I could have read, 3 additional CTs in that time. And if we had an effective LLM to comb through that chart, not only through the charts at my home institution, but the charts that had been uploaded from outside institutions, the IR reports, the CTs, the MRs, the radonc notes, the oncologist notes, I wouldn't have had to struggle like that. And I could have extended care to additional people that day. So I think there's a lot of room to implement LLMs to help synthesize all of this complex information that's unstructured and is coming from so many different sources.
That's a great anecdote to highlight that issue specifically. And, when we talk about practicing a top of license, it's certainly not top of license to be scrolling through pages and pages of text. What's top of license is for you to ask, was a coil implanted, was a radiation seed implanted in this patient, and to get an answer and then validate that. So that's a really great example. All right. So it seems like the panel is sort of sharing the excitement about how this is going to find its way into our practice. I think there's a lot of work that needs to go into understanding how this technology works and also how it fails, so that we can safely incorporate it into our practices. So getting an answer to a question that you ask a large language model that sounds credible does not absolve you from the need to then validate that in the record. But that's still a much more efficient process than looking for a needle in a haystack, to Ashley's point. So I think there's going to be a lot of use for that. If you haven't played with it, I would really invite any of you audience members to go play with it. It really transcends a lot of traditional barriers, language barriers. I'm originally German, so I've actually taken de-identified reports and had them translated, and out came some very idiomatic reports that sounded like a native speaker. I think there's a lot of opportunity that's actually also highlighted in the opinion piece that I referenced earlier, to translate reports into patient-friendly reports. You can, in fact, tell the engine to formulate the report for 7th grade understanding, 10th grade understanding, and I can confirm that it does actually make a difference. And so you can really fine-tune that to the patient's needs. The article actually also raises the possibility of doing conversational style interactions with patients about preparation for examinations and reassurance about how the examination will be performed and things like that. So it's clearly early days, and we're going to embrace this and work to inform our members on this.
Chris, if I could raise a question back
Please.
to you and Keith and Bibb. The framework of this discussion has been what radiologists might do in the practice of radiology. But in fact, with the large language models, the borders between radiology and all of the other specialties are going to blur.
Yes.
And, we spent years and years developing the appropriateness criteria for ordering radiology exams. These are likely to come under review in the large language model era, and not necessarily by radiologists. So I think we need to have a strategy of reaching out to at least the larger referring specialties to see if we can harmonize the use of these models, particularly when it comes to things like appropriateness criteria. I'd be interested in others' comments.
Yeah, I think we've done some experimentations at ACR. You can actually use so-called meta prompt, which is like to tell the large language model to apply one or another set of appropriateness use criteria. So you can actually make that a constraint of your question to the bot about what is the appropriate next step, and we'll make it specific for imaging. That then also means that institutions can choose to program the use of their engines in such a way that the preferred criteria will always be applied. So in a way, you can almost engineer a single or multi-guideline use when such questions are being asked in your health delivery enterprise. So that's probably a more reliable way of bringing appropriate use criteria to bear in clinical practice than to hope that your practitioners are individually understanding or using them. So I think to the at scale comment that Ashley made earlier, this probably allows you to leverage that insight at scale in institutions. What do others think?
I was going to say, this is a tough time to make predictions because it's so early. But if I had to kind of just guess based on what I've seen, so my biggest gripe about the last 6 years of AI is back to Jim's point, is that this stuff just doesn't generalize well. It was designed to solve a specific problem with specific data. And if you think it's going to do something else, like be able to diagnose on a different age than it was trained for and a different device than it was trained for, it fails. This is the exact opposite. This has been trained on everything in the world, internet, and it fails for a different reason, because it's not specific enough. And so I think the magic is going to land this stuff right between the two. So for example, what people are doing to look at to solve this problem of hallucination is to say, to what your point, Christoph, is to say, okay, you say, like to Ashley, you say that's a coil, and you say that was placed in 1984. Prove it to me by showing me the chart that says exactly that, right? And so it's this combination of generally understanding everything and then specifically answering the question. I think that's going to be the magic. So like Christoph said, Jim, what we're doing at the ACR was, we said, given this chunk of a patient's medical record, tell me the exam that's most appropriate, but do it by referencing the appropriate spot in the appropriateness criteria of the ACR. And it comes back and tells you which one of the appropriateness criteria is necessary. I mean, it's an interesting question to ask, but is it going to be better that you have a referenced information that is maybe old? It's not, current as of a week ago, maybe a year ago when it was written, or is it better to have a little bit of hallucination, not so deterministic, a little more stochastic, and get an answer that it comes up with?
So Keith, do you think we can resolve the dueling criteria by looking at outcomes, allowing the large language models to actually look at outcomes from, let's take screening mammography for breast cancer.
Yeah.
We have at least 3 or 4 different sets of appropriateness criteria promulgated, by the federal task force, by different professional organizations. And we certainly have our point of view from radiology. I see an opportunity using generative AI to harmonize these.
Yeah, I think that's right. I think, it's a different form of feedback loop, but I think that's how you're going to make this generative AI be more accurate in our domain. The other thing that people are doing are training or fine-tuning this stuff on healthcare data specifically, because think about all the inaccurate stuff on healthcare that sits on the internet, and that's what it's telling you. So now you can fine-tune, and I think, Jim, that's another way to do that, is to say, let's look at millions of outcomes based on this information, and now give me information that you can tell me why I should be doing this versus that.
Yeah. It's an interesting question, Jim, because I think that this technology will really begin to break down silos between professional societies, between specialties in delivery organizations, because it just makes so much information so accessible. It's going to be very interesting to see that play out. I did want to go to Bibb for something that he's maybe best positioned to address. This is sort of a switching gears moment. Bibb, you've spent a lot of time with ACR, the national organization in the economics areas. And so one of the barriers that we've seen for implementation of AI, apart from technical and workflow challenges and narrow focus and so forth, has been the lack of generally applicable payment model for this technology. So all of our practices are sort of putting this in at our own expense, more or less, with a few notable exceptions. Can you please elaborate a bit on the economics of AI, sort of past, the current, and future trends that you see? Because we certainly do need some help here on the economic side to bring this technology to bear for our patients.
Well, thank you, Christoph, and you're right. I have spent most of my time of volunteer work with the college doing economics, and I think that we have to recognize that AI is a little bit different than when we developed MRI, and we had MRI. And so we have an MRI of the brain, and we have an MRI of the spine, and you can have a CPT code, and it describes what we do and the, the various, well, is there contrast, is there no contrast, is there without and with contrast, and we have that lexicon that describes that. And then we come into AI, and we have an AI potentially that describes a segment of the interpretation of the CT scan of the brain, or a segment of the CT scan of the chest. And we want to say, well, we want to have a payment for that. But if you look at what's already out there, there's already a CPT code that describes CT scan of the chest. There's already one that describes CT scan of the brain. So in the payment policy world, AI is going to compete to some degree with the payers won't say, well, we need a new code for CT scan plus AI, because aren't we paying you to interpret the CT scan? Why do we need to pay something else to interpret the CT scan? And I find that a little bit troubling. And then in particular, when we have the AI that's out there, and I mentioned I called it low-hanging fruit a little bit, but it really is all of these triage applications whose job it is to identify a critical finding, move that to the top of the work list. That's not exactly providing medical care. Now, a couple of problems that I see that entails. So how do we do that? And the first one is that we see a lot of AI being, Jim and Keith have the luxury of practicing in an environment where there's a big endowed mission for research and having the newest technology, and a lot going on right there. In my community hospital in mid-sized town, Alabama, we don't have the opportunity to do that. And so, we're having to spend all the money out of some other operational thing to bring in AI. And so we need to think about what the value proposition is. What is the value? So rather than focusing on what the AI is doing, focus on what the AI is helping us. So these triage applications, for instance, can we make a case for our hospitals that we can decrease ED turnaround time? Can we make a case for our hospitals that we can decrease length of stays? And then all of a sudden, there's a big value to bringing the AI into the clinical workflow without having to have a payment. I'm a big fan of saying, well, couldn't the models basically live with the modality? And I know that there are a lot of technical challenges, but if your pneumothorax detector lived on your portable chest x-ray unit, and it was just part and parcel to the software upgrade, I'm old enough that I can say that we've all, I remember our initial 1.5 Tesla magnets with slow gradients and, did nothing. And we paid about $1.5 million for it. And now you can buy a 3 Tesla magnet with all the sequences and all the stuff. And guess what? We pay about $1.5 million for it. So I see the ability to bring that technology into how we do that, how we pay for it, how we depreciate the value of that equipment. The other thing that I see is doing the things that humans can't do. The things that have CPT codes now, that are having payment made now, are all of the things that do things that humans can't do. So the quantitative functions, Ashley's going to love the fact, that there's going to get fractional flow reserve paid for, to some degree for starting in 2024.
Absolutely.
So, but because it's doing something, as that humans can't do. quantitative stuff for liver or for pulmonary emphysema or whatever you want to say. Population health, the work that Perry Picard is doing about, looking at all the patients that come through our ED and then finding things, figuring out how to translate that into the medical record for atherosclerotic calcification and liver and BMI and muscle mass and all of those types of things that we humans really wouldn't do in the course of routine care, but can be really impactful for patients. And so I think that that's a little bit of the direction that we need to consider. We need to help get the regulatory process where it allows the companies and the developers to get their stuff cleared and bring that stuff into practice, that the barriers aren't too high. And so I think, in a nutshell, that's kind of, where I see the economics right now.
That's great, Bibb. I really like the strategy of tying the future of the use of this technology to its actual value proposition in our healthcare delivery, and then basically finding the right spot for it that way, rather than approaching it from the conventional sort of fee-for-service mentality. So I think that also dovetails with Ashley's comments from earlier, that AI really has can have a completely different value proposition than I
really think that I would be remiss if I didn't mention, and I think that this is something that as an organization, the college committed to health equity and those issues. If you look at where AI is, it's in the hospitals that have the superstar radiologists, the subspecialists in radiology, the radiologist that only reads spine, but really only reads tumor spine. I mean, you can go down the line, and that's who's getting the AI. The small and rural hospitals, the poor county hospitals, the underserved, areas aren't getting AI because they're not able to pay for it. And I think that our government payers and everyone needs to understand that it's very important that we don't limit the deployment AI to the big, well-funded, large centers, but really get AI deployed in the places where it's likely to impact patient care the most.
That's actually a great segue for the last little topic that I wanted to hit on, the 5 minutes or so that we have. Jim actually points out in his article from 2017, one of the key tenets, and that is imaging is a truly digital specialty. And so at the core of what we do, everything's portable, everything's digital. And where I wanted to go with this comment to see your reactions is, with that as the backbone, I think that radiology is really global. And I think that the application of AI and the adoption of AI is global. And so I think rather than just taking a US-centric view, we really do need to look at what's happening in other parts of the world. And not surprisingly, and this is where this comment now is coming from, in parts of the world where there's not good access to imaging care and radiologist-based imaging care, there is a dramatically faster adoption of AI than we see in our country. And I think that that's number one, a confirmation, Bibb, of what you're just saying, is it does give access to something that's better than no imaging care to a larger swath of population. It's also something that we really have to watch very carefully how it's going to play out, and whether that is sort of truly a value proposition. Are there other reactions to what's happening around the world in the use of AI and what you're seeing, guys?
I think you've captured it very well, Chris. We ask the wrong question. Sometimes we say, is this as good as it would be at UCLA or Mass General? And the answer is maybe not. No. But is it better than it would have been without AI in a remote location? And Bibb, you touched on that as well.
Yeah, thank you. Keith, Ashley?
One of the things I think about is, I think this is somewhat related, is risk assessment. So there have been some models that have come out lately from our colleagues at MGH, looking, again, I'm going to touch on CT chest because that's my space, but lung screening, and not only looking at one exam, but looking at 6-year risk of developing cancer. So thinking about, how we improve care with limited access, if we have a huge number of people that need a study or need an exam and a limited ability to provide those scans, can we figure out which patients are at the highest risk and absolutely necessitate access to that limited resource? And we may be able to start realizing that with some of the AI models that are being developed to triage care.
Excellent.
That's an excellent point. And quite frankly, building on that, I think you're saying it, I think Bibb's been saying it in his comments, and it was also in the international comment, the current model by which we deliver imaging care is neither scalable nor sustainable. It works well where it works well, and it does not work well for most people or for a lot of people. So let's be honest. I think there's a moral imperative to find ways in which we, in combination with technology, used in the right way, can actually expand our footprint and the ability to reach patients.
I'm going to throw out a little interesting anecdote.
We only have 1 minute, so please be concise.
Well, I know I'm from the South, but I can speed it up a little bit. In my work with the International Society of Radiology, and the idea that if we can get to underserved areas, things like mammography, TB screening, and so forth, and use AI to help them decide who can go home and who needs to go to the clinic and that sort of thing, it would be huge.
Yes.
And it's very interesting because the hurdles, though, are deployment of a obstetrical ultrasound model that was built in Europe into Kenya, and it failed miserably. But they retrained the model using the local data, and they built a model that worked in Kenya and back in Europe, hey, it worked even better. So this idea of using techniques of transfer learning and federated learning can have the ability to do that as well, and tune the models for where you need them. So that was it. And I did it in less than a minute.
No, wonderful, Bibb. No, I think it hopefully inspires the larger community out there who's listening, that this is also a way in which you can become active in supporting communities far away from home. I think many already do that through Rad Aid and other similar organizations, but that is one way in which we can impact a lot of people. Well, guys, you've been a great bunch of discussants. We could probably keep going here for another hour. I really want to thank you panelists, Dr. Thrall, Dr. Dreyer, Dr. Prosper, and Dr. Allen, for sacrificing some of your precious evening time here so we can have a fireside chat about AI. I'd like to thank the ACR staff, especially Abby Faulkner, for their technical assistance. And again, the Centennial Committee for the ability to address this important topic of emerging technology here with a broader audience. There will be a rebroadcast of this available on the JACR's YouTube channel and on Twitter. So you can check the Twitter page for a link at JACR Journal to find this chat and also to submit questions. So thanks again. We'll post the articles that were mentioned here during this conversation. And I wish you all a good night, and thanks again to our panel.
Thank you.
Thanks as well.
Good night.
Thanks, everybody.